Hi, back again. Talk a little bit about forces. Now I wanted to discuss work and energy. Here we've got a description of work, mechanical work. We're talking about force through a distance. So we're taking a vector as a force and a vector as a distance, all right, also called a displacement. And they're along the same line, or they can be oppositely directed. Okay, so you take a force along a particular distance that can be at a particular angle as well, and then you can find the components of the force along that particular distance and then calculate the work. So force through a distance is called work. And work is really a change in energy. If I have an object and I raise it to a certain height, so for example I've got a ball over here. If I say that the zero in energy is the ground and I raise this to a certain height, I've increased its potential energy. I have a little formula here. We call it potential energy, the mass times gravity times height. Okay, so that's the potential energy. When I release the ball falls, loses its energy, loses its potential energy, but it's falling, it's increasing its velocity. We call that kinetic energy. So it loses potential energy but gains kinetic energy. All right? In fact, this is kind of a neat way of representing this in one particular aspect, or excuse me, one particular experiment is the pendulum. All right, so here I've got a pendulum. Let's swing it over here. Skelly, you can help me out here. So as I swing the pendulum, as it goes up, it's gaining potential energy. Here it stops. It has maximum potential energy. And then at the bottom, it's going fastest. It has its maximum kinetic energy. So here it's potential energy. At the bottom, it's lost all of its potential energy, but it has kinetic energy. Okay, so back and forth, a trade-off. So the total energy we can represent over here. So we've got our total energy is equal to the potential energy plus the kinetic energy. In thermodynamics, we say it's the work plus the heat, but here we're talking about mechanical energy in terms of potential energy and kinetic energy. So kind of an interesting way of looking at work and its connection to energy. So force through a distance is work, and we can change the directions of forces. If I wanted to go in one particular direction or another, I could, for example, have a pulley system. We can change the angle of the forces. So as we're doing work, we can change the direction of the forces. So a pulley can be useful. All right, we're changing the direction of the force. Sometimes you've probably heard of such a thing as the net force. What is the net force? Well, let's see. Sometimes the net force is some plus value, other times it's zero. Got a rope on one side, rope on the other side. If I pull with the same force left and right, and the ring here doesn't move, we say the net force is zero. Okay? I could also hang a weight on this third rope. We can then direct the forces sort of like an equilateral triangle, right, 120 degrees between all of the ropes here. So I've got 3 ropes on here. I'm holding up this clamp, all right. The net force is 0 on the ring. The ring is not moving, okay. So here the net force is 0. So we talk about net forces, we talk about forces and their connection to work. Really interesting ways to look at forces and energy. Okay, so in the next segment, I'd like to talk a little bit about potential energy and some neat ways to represent potential energy. So I'll be back then. See you then. Take care.